Okay. Okay, so we're going to be doing these problems where you have to test the points in the equations to see if they fit, which essentially means you plug in the x and see if it makes the y that you want it to make, right? Or plug in right here the x and y and see if it makes -6 or something like that. So I like this because plugging in values for variables is something that should be pretty simple, but I still see a lot of people get kind of confused by. So you know that the first number in a coordinate pair is x, and the second number is y. I hope you know that. My light keeps going off. Okay. So we're going to test one of the points, and then we'll test the other of the points. Where is my mouse? There it is. Okay. So first we'll plug in 0 for x and -1 for y. So in this one, that's -1 plus 2 equals 1/3 0 minus 3. Okay. So that is, I'm going to do this. Use a different color. Okay. So that is our x and y plugged in, right? And now we got to make sure that this makes a true statement. Let's see. Blue and red make purple. Oh. Oh, sorry. Okay, there we go. Thank you, Brandon. Brandon said you couldn't see what I was writing on. Okay. I hadn't shared to the right screen. Okay, so here's what I have. It's the same thing, but I am writing on it now. So, let me see. Okay, so -1 plus 2 is 1. And then we've got 0 times or 0 minus 3 is -3. 1/3 times -3 is -1. So what I have here is 1 equals -1. Well, that is a false statement. So this point does not work in this statement. That means that it's not going to be I. Or both. Since it can't be I, it can't be both. Because we tried a point and it didn't work. Okay. So we still don't know whether it's neither or 2 only. We got to try it in the second one to see. Okay. So this time I'll use red. So 2 times -9. And we'll have to use, I just realized this makes it seem like I'm using this point for this and this point for this. We have to try both of them in both of them. So I'm just going to use this one tested first, and then I'll test that one. So 2 times -9 and y times 2. I mean 6 times 2. Okay. All right. 2 times -9 is -18. 6 times 2 is 12. So we end up with -18 plus 12 equals -6. That is a true statement, okay? But we don't know for sure yet that it's number 2. We also have to test the other point. So the first equation, we struck off just from testing the first point. The second one made it past the first point. Now I got to test the second point. So so now we're back to x is 0, y is -1. Oh, I'm sorry. Dang it. I messed up. I'm so annoyed that I'm filming this and it's going to be on video now, but I don't want to start over. Okay. We were supposed to do this in this equation. We already canceled that equation. Sorry. Oh, wait. All right. Now we're using the other point. That's what I meant, not the other equation, the other point. So 0 for x, right? And -1 for y, plugged in. 2 times 0 is 0. 6 times -1 is -6. So this says -6 equals -6, right? 0 plus -6 equals -6. And that's right too. So both points worked for the second equation. So I'm going to go back here and say 2 only. Okay. I submit and it works. So see, in the explanation that it always gives you, here it tests both points in equation 1. I didn't make you test the second point in equation 1 because I already knew after the first that it had to be false. And then testing the points in equation 2, it does work out. Okay. Okay, this one I won't mess up on, so it'll be a little easier to follow. Which of the following equations represents a line that passes through the points -4, 5, and 6, 0? All right, so okay, I'm just going to say points are in red and equations are in blue. So first we'll test the first equation. So we'll try the first point, -4. And the second point, and the y is 5. Three times -4 is -12. 6 times 5 is 30. So we end up with -12 plus 30 equals 12. Well, I think that -12 plus 30 equals 18. So I'm going to say it's not this. That didn't work, which means it can't be this and it can't be this. The same as last time. Didn't do that on purpose. I don't know what problem I'm getting when I do these things. Okay, so let's try it with second equation. So y is 5, x is -4. So -1/2 times -4, we've got 5 equals -1/2 times -4. Negative times negative is a positive, and half of 4 is 2. So 2 plus 4. So 5 equals 2 plus 4. Well, no, it doesn't. 2 plus 4 is 6. So it can't be this either. So it has to be neither. We'll choose neither. Boom. So here I got 18 and 12. Here I got 5 equals 6, etc. Neither. Okay. I'm kind of hoping, let's see. Okay. Let's do this one. All right. Last one. So we have our x and y. Okay. So let's try our first equation. Two times, the first point has x is 0 and y is 7. So 2 times 0 is 0. 6 times 7 is 42. So 0 plus 42 equals 42. Sounds right to me. But we still got to try the second point in it. So let's see. So 2 times -9 and 6 times 10. Okay. 2 times -9 is -18. 6 times 10 is 60. So -18 plus 60 is 60 minus 18, and that would be 42. So in this case, the first equation does work. So we know it's not neither, and we know it's not 2 only. It has to be either 1 only or 1 and 2. So now we got to see if it works for 2. So x is 0. Y is 7. -1/3 times 0. Well, anything times 0 is 0, so that makes 0. So 7 equals 0 plus 7. Boom, works for me. And this is the final question. If it works for this, then it's 1 and 2. If it doesn't work for this, then it's 1 only. So now we're trying a second point. So x is -9. And y is 10. Okay, -1/3 times -9. So negative times a negative is a positive. So whatever it is, it's going to be positive. 1/3 times 9 is essentially 9 divided by 3, right? 1/3 of 9. 9 divided by 3, how many 3's in 9? Is 3. 10 equals 3 plus 7. That is right. So both of them worked for both of them. So this one should be 1 and 2. Ta-da! Beautiful. Okay, any questions? Does this seem simple enough? We just plug in the points into both equations. And as always, if you get, whether you get it wrong or right, you can always look at the explanation after you do it. And then if you got it wrong, you can look at the explanation and be like, oh yeah, that's what I missed, and then do the next problem right. Okay, it's just testing both points in equation 1 and in equation 2. Okay.